So here we have the same sensitivity and specificity, but a different incidence rate. Okay, so again, sensitivities remained at 50%, specificity remained at 99%, but our incidence rate has gone from 80% down to 4%. Okay, now what effect has this had on the positive and negative predictive values? Well, it's actually quite dramatic. So previously we had a positive predictive rate of around about 99%, basically saying that if you had a positive test, or if your patient had a positive test, it was very, very likely that they had the disease within this given population. Here we can see that that's slightly changed. So now, rather than it being for roughly every 100 people who have a positive test, only one of them won't have the disease, so 99 of them will, we've gone to now only 63 of those 100 patients would have the disease, so that's quite a high rate. So roughly a third of them with a positive test will not have the disease. It's had a really, really dramatic effect on our NPV with the numbers that I've chosen. So with our negative predictive value, 98%, so if you definitely don't have the disease, we can say with quite high clarity, if you have a negative result, we can say with very high clarity that in all likelihood, it's very, very likely that you don't have the disease. So out of 100 patients, only 2 of them will not have the disease. Only 2 of them will have the disease. So it's very, very low. And this is all to do with the incidence rate. Now, the incidence rate is obviously within studies itself. It's very much linked to the sample population that's being taken. And this is why when we look at screening studies, because the sample population is quite wide, because it tends to include asymptomatic patients, that our negative predictive values start to increase, because the incidence or the prevalence of a particular disease is very, very low. So using an incidence rate of around about 4. So remember before we said the incidence rate sort of ranges between 1.2 to 6 for females and 7.4 to 18 for males. But again, this depends upon the population that's being drawn from the study. So it does help inform practice in a certain way. This is the theory as well as to why GPs tend to investigate patients and hospital physicians tend to over investigate patients, because of course in a hospital setting you've already got people who are poorly and presenting with symptoms, so you're more likely to investigate. Within general practice, because you're looking at the entire population, you're less likely to investigate, because perhaps the disease prevalence that are initially associated with those symptoms are actually quite low. So it does have its uses. So hopefully you found that useful. But also have a look at the example on the sway, because just underneath this video we'll be talking a little bit about screening as well.